Today in this video, we are going to learn how to calculate the packing efficiency of different type of unit cell. So first of all, what is packing efficiency? Packing efficiency is the percentage of total space filled by the particles in the given volume. Formula for the packing efficiency will be volume of atoms present in a unit cell divided by volume of unit cell multiplied by 100, because we are calculating the percentage. Now, when we talk about primitive unit cell, how many atoms are present in primitive unit cell? So number of atoms present in a unit cell is 1. Okay, now how we got this? You can see that in primitive unit cell, at every corner, 1 atom is present, but it is contributing only 1/8 part in this unit cell. So we can say that 1/8 multiplied by 8, because there are total 8 atoms at every corner. So the total number of atoms will be 1. So to calculate the packing efficiency of simple or primitive unit cell, volume of one atom or particle which is spherical in shape, and volume of sphere is 4/3 pi r cube, and we are taking the edge of this cube as a. So volume of cube will be a cube multiplied by 100. Now the next important thing is to find out the relation between a and radius of this atom. Now in this figure, if I take this point as k, so from E to K, this is the radius of one atom, and from D to K, this is also the radius. So we can say that A equals to R plus R, that is 2R. So we can substitute A with 2R here. So we can write it as 2R whole cube multiplied by 100. Now 4/3 pi r cube multiplied by 1 upon, when you do the cubing of this, you will get 8R cube, then multiplied by 100. Now we can cancel R cube with R cube. We can cancel 4 and 8, so we'll get 2 here. We can cancel 100 with 2, so we'll get 50 here. Now we can put the value of pi, that is 22/7, and we'll get 50/3. So finally we are getting 1100/21. If you are going to divide it, you will get 52.38%, which is equal to 52.4%. If you do the rounding, so packing efficiency of primitive unit cell is 52.4%. Now, packing efficiency of body-centered unit cell. Now, what is the meaning of body-centered? When we talk about body-centered, an atom is present at the center of the unit cell. Okay, so firstly, we'll calculate the number of atoms which are present in the body-centered unit cell. So here, this one atom is present at the center of the body. So 1 plus, and 8 atoms are present at every corner of this unit cell, but it is contributing only 1/8 part. So we can say that 1/8 multiplied by 8. So 1 plus 1. So it means total 2 atoms are present in body-centered unit cell. Now to calculate the packing efficiency, we'll write 2 multiplied by 4/3 pi r cube, because there are 2 atoms which are spherical in shape, multiply upon a cube, then multiplied by 100. Now the next task to find out the relation between A and R, which is very important because we have to substitute A with in terms of R. So firstly, see this triangle EFD, which is a right angle triangle at E. Okay, I am drawing it here separately. So this side is A, this side is A, and this side we are taking as B, which is the diagonal of this base. Now, if it is 90 degree, and if you are going to apply the Pythagoras theorem, so you will get B square equals to A square plus A square. So B square equals to 2A square. So B will be √2A. Okay. Now I will take triangle AFD. I'm highlighting it in the figure. Here angle D is 90 degree. Now if we apply Pythagoras theorem in this triangle AFD, okay. So here the hypotenuse, here the hypotenuse is AF, AF square, base is DF, and perpendicular is AD. Now AF, now here if you see AF, okay, so this is made up of this radius of this one atom and diameter of this center atom and radius. So you can say that AF is equals to 4R. So here we can write it as 4R whole square. Okay. And DF is equals to B, and we have got that BF is equals to root 2A, to root 2A whole square, plus AD. Now AD is equal to edge of the cube, that is A square. So you will get 16R square, root 2A square will be 2A square. And here you will get A square. So you are going to get 16R square equals to 3A square. Now if we write A in terms of R, so we are going to get A is equals to 4R upon root 3. So this value we are going to substitute here. So if I write here 2 multiplied by 4 by 3 pi r cube, and we can substitute A with 4R upon root 3 whole cube multiplied by 100. Now when we are going to solve it, we'll get 8 by 3 pi r cube. Do the cubing of this, so you will get 64 upon the cube of root 3 will be 3 root 3 r cube multiplied by 100. Now this expression can be written like this: 8 upon 3 pi r cube multiplied by 3 root 3 upon 64 r cube multiplied by 100. Now what can we cancel? We can cancel r cube with r cube. Okay, we can cancel 3 and 3. We can cancel 8 and 64. So we are going to get 8 here. Then we can cancel it with 4. We'll get 2 here. And we are going to get 25 here. Okay. So in this way, now what we are getting? We are getting here 25 value of pi we can put, that is 22 upon 7. And we are getting 25 root 3. Okay, upon 2, and further we can cancel 2 and 22. So 11 multiplied by 25 root 3. When you put the value of root 3, we can take the value of root 3 as 1.73 upon 7. When you multiply all these three values, you are going to get 475.75 upon 7. And if we divide it, we'll get 67.96, which is approximately equal to 68%. So packing efficiency of body-centered unit cell will be 68%. Now we'll talk about next unit cell, which is face-centered. Okay, so the first task is to find out number of atoms. Okay, now what will be the number of atoms in the face-centered? First of all, what is the meaning of face-centered? Face-centered means an atom or particle is present at the center of every face of this unit cell. So in cube, there are total 6 faces, but if you see that this face-centered atom is contributing only half part of it in the unit cell. So half multiplied by 6, because there are 6 faces. Okay, and 1/8 multiplied by 8, because 8 atoms are present at the corners also, and which are contributing only 1/8 part. So what we are going to get here, we are going to get 3 here and 1 here. So total 4 atoms are present in the face-centered unit cell. So here, to calculate the packing efficiency, we'll write 4 multiplied by 4 by 3 pi r cube upon A cube multiplied by 100. Okay, so the next task is to express R in terms of A. So for that, I'm going to take this triangle. Now, name of this triangle is triangle ADC, which is right angle at D. Here, AC is the hypotenuse. So AC square equals to AD square plus DC square. Now, AC will be equal to 4R because this part is equal to radius. This is equal to diameter 2R, and this part is also equal to radius. So AC will be equal to 4R. So we can write it as 4R whole square. And AD is equals to A because we are taking edge equals to A, and DC is also A. So we'll get 16R square equals to 2A square. Okay, or you can say that 8R square equals to A square. Now we can write it as 2√2 R equals to A. Okay, so this is the relation of A and R. So here we can write it as 16 upon 3 pi R cube, and A is equals to 2√2 R. So 2√2 R whole cube multiplied by 100. Now we can write it as 16 upon 3 pi R cube multiplied by 1 upon. Now the cube of 2√2 will be cube of the cube of 2 will be 8, and cube of √2 will be 2√2. So you are going to get 16√2 R cube. Okay. Now we can multiply it by 100 also. We can cancel R cube with R cube. We can cancel 16 with 16. Okay. So finally, what we are going to get, we'll put the value of pi also, that is 22 upon 7. And we have got 100 also here. Okay. Upon the value of √2, we can take it as 1.41, and 3 is also there. So we'll get 2200 upon, when you multiply all these three, you are going to get 29.61, and when you will divide it, you will get 74.29, which is approximately equal to 74%. So in this way, we can calculate the packing efficiency of different type of lattices. Stay connected for some more important topics of chemistry. Thank you.